Hello everyone, and welcome to this C++ engine programming with the nCine series of video. This is part 1, and I'm going to give you a little presentation about what the nCine is and an overview about its features, about the development tools that I've used. As you can see on this first slide, there is a link to the website, so you can go there if you're very curious and have a look for yourself. First, some words about myself. I'm Angelo Fedoru. I was an industry engine programmer in the past. A lot before that was an Amiga nCine lover. That's how everything started for me, the interest in real-time graphics, in game developing. And I'm an Arch Linux enthusiast. I use Arch Linux every day. I've been developing the nCine on Arch Linux, and as you can see now, I'm recording this on my Arch Linux workstation. I've been developing the nCine since 9 years now. It was 2011 when I first started. But what is the nCine? Well, first of all, as many of you have asked me in the past, what's the meaning of nCine? It's very silly actually. It's my nickname, Ancelo, plus engine, and you have nCine. It's a cross-platform 2D game engine. It works on Linux, on Windows, Mac OS, works on Android, and it works on mScripten as well, means the web. You can use it for your games, you can use it for small prototypes, think about Game Jam for example. You can use it for your tools. You have access to some GUI toolkits that you can use, and this gives you the power of create tools with it. And you can use it for your demos. They can be 2D demos, they can be 3D demos if you compile the library statically so that you have access to the OpenGL low-level layer. And it's open source with MIT license, which is very permissive. You can use it commercially, you can do whatever you want actually. And that's important as well. It's small enough that you can actually understand it. And with those videos, I hope it's even simpler for you. Let's see what the main features are. It is written in C++11, and that's the main language that you would use for your games and tools, but it can also be scripted with Lua. The Lua API is not full, doesn't have all the C++ API power, but you can still do like small games with it. One other feature that I'm kind of proud, it's the automatic culling and batching of sprites. So sprites are the main 2D brick that you would use to create your world, and having automatic culling and batching means that performance-wise it's going to be fast enough. It uses a custom templated library, so I don't use STL. I've recreated many containers with all their iterators. I have many low-level things like a unique pointer that I've re-implemented myself, and it was in the beginning something that I've done for actually learn C++, templates, metaprogramming, and feel confident about it. But with time and with a lot of testing and benchmarking, I discovered that this library is decent enough, and I use it throughout the whole project, and I've discovered that this library, it's actually quite reliable and has pretty decent performance sometimes. You can use the nCine with multiple desktop backends. You can use it with GLFW, you can use it with STL2, and you can use it with Qt5 as well. And this has some implications. For example, if you use it with Qt5, it means that you can have a Qt5 application with all your widgets, and in the center or wherever you want, you can have the nCine rendering into a custom widget. You can use this feature for example, have a tool which is made with Qt5 and still have your game output rendering somewhere into this tool. And it's also integrated with ImGUI and Nuclear. They are both immediate mode interfaces, but they are quite different. So DRMGUI is more flexible and more powerful, but Nuclear can be skinned easily. So my thinking was that you would use DRMGUI for the tools and you would use instead Nuclear for the game GUI. It's also integrated with the RenderDoc and Tracy, and it's important from a point of view of debugging and profiling. RenderDoc is a graphics debugger, so using it you would be sure that your frames are rendered correctly, while with Tracy you would profile your frame time and see if what you have coded it's actually performing in the way that you expect. Those are some screenshots with some of the features. Here is a screenshot about Lua Script, which is actually a game using the nCine API. This is a screenshot from RenderDoc showing batching of quads. So you can see here that there are many degenerate vertices, and those are used to draw multiple quad with one render call, and it's all made automatically. Those are some particles rendered inside the particle editor tool, but they are using the engine API, which means you can have the same results in your game as well. This is the IMGUI integration, showing a debug overlay that every application will have. You can use IMGUI for your own interface, for your game widget, for your editor, but you would have this debug overlay always at your disposal if you want to check that something is working the way that you think it should. And this is a screenshot from the trace integration. You can see some zones. So those zones are actually markers put inside the code. The code is instrumented and has starting and ending point. Tracy will calculate the time between those markers and will show you what's happening with your code. You can also show memory allocations or custom variables you can plot. For example, vertices, how many draw calls you have, just by instrumenting your code, and then you will see those numbers in the Tracy window. Those are some of the development tools that I've been using for the nCine. CMake is very important for everything related with building or for creating packages like installers. And it's also very important to keep everything working on every platform. I also use both Google Testing Library and Google Benchmark Library. I use them extensively for my STL kind of library to ensure that it's working with correct results and it also performs well. Using those libraries is not enough because you don't really know if you have coverage of your code. That's where gcover enters the scene. They will highlight what path into your code are taken by those unit tests, because you can never be sure. Even if you create a test that you think it's taking all the path into your code and it's testing everything, you will never really be sure if you don't let those tools help. I also use CPP check and bulk grind. The first is a static analyzer for C++ code. It will just read your code and create a report about issues. They can be false positives, and you can then later check this report and see for yourself what's happening. And bulk grind, I use it mainly for the memcheck tool to see if there are any memory leaks in the code. I also use Clang format to format the code to have a consistent style throughout the whole code base, which is something very important for readability. And I use Doxygen to create the documentation. Doxygen will parse my source code and extract all the comments that I've put there to create a page for every class inside my code. This is a screenshot from Qt Creator. It's my IDE of choice, and I like very much the Google Test integration, the way it will scan your test and see if there is any new test that you have added, and of course the way to report if a test is passed or not, and the way you can select just some tests to run, the way you can debug them as well. So I like very much this feature. It's working pretty well. The integration is good. And that's an example from a report from gcover about the coverage. You can see here of a class, and those green lines are the lines that are really being executed by a unit test. And here an example of a Doxygen documentation page of a pretty easy class. You can see it from the collaboration diagram, which is generated by Doxygen together with GraphViz. This is the size of the project. In this table you can see a breakdown of how many C++ lines you have, how many of those are headers, how many files, blank lines, comment, or real code. Those might seem like many lines, but actually they are not. So they've been written by me alone, which means they can be understood by one person. But it's not like those are the whole number of lines that I've written, because many subsystems you rewrite many different times because you learn maybe to do something in a different way or a better way. For example, the rendering system has been written currently 3 times, and I don't think it's going to be the last time. The nCine repository is not the only repository that you would find on the nCine organization page on GitHub. You have the nC template project, which is a CMake based template project that you can use as a starting point to create your own game or application. And it has some CMake scripts to make the project that you're going to write compatible on all platforms, and you will be able to create installers of your game or tools thanks to this template scaffolding project. Based on this project, there are some other games. For example, I have a Pong, which is written in both C++ and with the Lua API as well. There is a simplified Space Invaders game, And there is a particle editor, which is a simple tool which you can use as a starting point and see how can you mix AmGUI with the nCine rendering as well. And then there is nCine, which is kind of a different tool. It's a command line only tool which will help you compile or download libraries. It will wrap CMake calls, so you don't have to understand everything about CMake. And it will also download archives from the continuous integration system that I have, so that if you don't want to compile library, or if you don't want to compile the nCine or a project, then you can just use nCine and download those, ready to run for all the platforms. This is a screenshot of the Pong game. It's very simple, as you can see. Here is Space Embedders, and here is the particle editor. This is a list of potential topics that I was thinking about. Some of those topics are pretty extensive. They can be splitted into multiple videos, of course. And also I would like to have a feedback from you. You can write me a comment underneath this video and let me know what you think it's most valuable for you, more important, more interesting. I can talk about the CMake build system, those 3000 lines that keep everything together on every platform. I can talk about the templated library and all the template metaprogramming in use. I can also talk about how I unit test and how I perform micro benchmark of this library. Or I can talk about the initialization system for the engine and how everything is glued to your application. I can talk about the input system and the events and how the keyboard is handled, how the mouse or the gamepad is handled. There is the scene graph, which has a node hierarchy of transformations, of sprites, of animated or mesh sprites or text nodes. And then this is flattened out to queue of rendering commands, and this can be another potential topic. So how I extract data from the nodes, put them into those rendering commands that only know about rendering, but they don't know where this information came from in the first place, and how those queues are sorted and then rendered. And I can also talk about the sprite batching, which builds upon this system. So you have sorting and then you have batching of those sprites. So those queues are then splitted into some batches which have compatible rendering characteristics. Or I can talk about audio, the OpenAL system that I have in place using OpenAL sources and buffers. Those are the main resources. So I can talk about how I handle those. I can talk about the Lua binding, the Lua API, and the way I handle the binding inside the engine, the way I handle memory of the C++ classes from the Lua API, which can actually create those. And I can talk about those integrations that I've shown you before. I can talk about AmGUI, Nuclear, or tools like Tracy and RenderDoc, how you can use them as a user and the way I've integrated them inside the engine. Or I can show you the particle system, the thing that it can do, and some tricks to make rendering faster. I can talk about texture loading, the way I use libpng or libwebp to directly load those formats, or how I load GPU compressed formats, or how I handle and parse GPU texture containers like KTX or DDS. And then there is a threading system and the file system abstraction. Those systems have a POSIX implementation for all the platforms and a Windows implementation just for the Windows platform. The threading system is incomplete because it's not really used in the engine, and it's not actually something that you can use as a user unless you compile the library statically. But it's still something that is there and works and can be something for the future. It's a starting point, so I can talk about that. And I can talk about the file system abstraction, how everything works with the same API, actually, this file system nCine API, but then underneath that there is a layer of system dependent code, POSIX and the Windows layer. Those are some topics I can talk about, so let me know in the comments what you think about those. If you have any other idea, of course I will show the code, I will show debugger, put breakpoints, and I will follow the code to make everything easier for you. See you in the next video.